Alright, so in the other video, we were looking at a type of explicit formula for an arithmetic sequence. And you can think of explicit, you can just find any term with it by directly subbing in a value for n. The recursive formula, on the other hand, it's specifically meant so you can find a next term in a sequence. I always use, personally, the explicit formula, but it's helpful to kind of just know that this one's around. So let's look at the formula for it. We have a sub n, still the term we want, is going to be set equal to, we find it, that's kind of how I view that set equal to, of how we find it, through taking a sub n minus 1. And n minus 1 is this n right here subtracted by 1, right? So whatever term position we want to find. And you're going to add that to the common difference, which is d. And d, common difference, again, is just that number we're adding or subtracting by, right? I'm going to change the thickness line thing again on this. There we go. All right, and if you can see down here in this little part, I put in all caps, arithmetic sequences create linear functions, which I think is an important distinction to make, especially when we get to geometric sequences and later when we get to like slope int form and all that jazz. But right now, just try to remember, if you can, that arithmetic sequences create linear functions, which I promise you it will make much more sense later. All right, so let's try to find a term using the recursive formula. So we know that 4 is the first term, right? It starts off the sequence. And then what follows is 9, so that means it's the second term. We got the third term, and we got the fourth. And that goes on forever. Let's pretend we don't have a sub 4, right? I'm going to find a sub 4, or 19. We're going to find that through taking a sub 3. But how did I get that? Isn't it a sub n minus 1? You remember that you're going to, with n minus 1, you're taking this, right? And subtracting by 1. And if you subtract 4 minus 1, you get 3, right? Which means this right here is going to be term 3, which is this 14. For the common difference, well, let's look at that. From one term to the next, what are we changing by? We're changing by 5, right? 4 being our starting position, then going 5, 6, 7, 8, 9. Same for 9 to 14, and 14 to 19. We're changing by 5 consistently. So that means our common difference is 5. So we already have a sub 3, right? That's our 14. So we can just add 14 to 5, which is equal to 19. So we can confirm that 19, a sub 4, they're equal to each other.